Hello, my name is Lo Tianrong, and I'm the group leader from Group 1, 1D. Today we are going to present about the TAO 6123 project. So this is our group members. This is Tan Peng Kai, and this is me, and Mandra and Nawas. So about the table of contents, we have paper reviews, SMP cache, GitHub, and conclusion. So the first paper review is mine about the evolution, challenges, and optimization in computer architecture, the role of reconfigurable systems. So about the overview of this paper explores the evolution of computer architecture. It highlights the needs of the energy efficient and high performance computing systems due to limitations like the power wall and the end of Dennard scaling. So for the applications, we have the machine learning AI like the chips like TPUs and flex TPUs are used to speed up AI tasks. And the data centers that about of Microsoft Catapult project shows how FGPAs can accelerate internet services. So the key benefits are the energy efficiency, scalability, faster performance. And the challenges are the software compatibility, like many programs are not designed to take full advantages of parallel or heterogeneous architectures. And that's all for my paper review one. Thank you.
Hello everyone, for my paper review, I read the research survey titled Edge Computing for Internet of Everything by Kong and others. The paper explained how edge computing helps in speed up data processing by doing tasks closer to the devices, instead of relying on faraway cloud servers. This becomes very important in smart cities, healthcare, and retail, where quick decisions matter. I found it interesting that edge computing works with AI, blockchain, and even 6G in future. What stood out to me was how simple like local data processing can improve systems like traffic light and medical machines. Even though some technical words were hard to understand at first, this paper helped me learn how edge computing is becoming a key part of smarter and faster technology systems.
Hi everyone, I am Mahindra. So today I'll be talking about my own paper review and also the SMP cache. So for the paper review, I've chose the research paper titled A Survey of CPU and Memory Simulators in Computer Architecture. So as a summary, this paper review highlights its importance in computer architecture research, and it touches up some of the applications of it, such as hardware design verification, architecture exploration, and deep learning workload simulations. Some of the key benefits I get from reading it are highly flexibility for testing scenarios and its emphasis on compiler simulator code design. However, I do find that this research paper consists of too much dense text and doesn't have any visuals to support some of the concepts. So, in my opinion, this paper was very insightful and it sparked my interest in memory simulation.
My name is Tan Peng Kai. I will continue to handle the presentation from paper 4 review. So the overview of paper 4 review is evaluate computer architecture components using SPSS statistical analysis, and the application mentioned in the paper is about education, CPU design research, and the computer architecture assessment. And the key benefits mentioned in this paper is around identifying reliable components and emphasize energy efficiency and scalability. So from this paper, I learned how basic stack tools like SPSS can support hardware evaluation. That's all for the paper 4 review.
Next, I'll be talking about SMP cache. So, what is an SMP cache? It is a trace-driven simulators for it to analyze the miss rates of the cache sections and also cache memory systems in a symmetric multiprocessor. So, this is the logo of SMP cache, and this is the UI of SMP cache. So for the implementations methods, there are four of them. The first one is to configure the desired settings, which is to change the settings on multiprocessor, main memory, and cache sections. And then after that, we need to obtain the trace files. So there are more than 9. So I listed 3 of them, which are hydro.prg, NASA server.prg, wave.prg, and so on and so forth. And then the third one, to check its miss rate of the cache memory, we need to change the number of processor and also the cache size. And then finally, is just to see the miss rate of the cache of the trace file based on your selected cache size and number of processor. So this is the example. So let's say for the blocks in cache, I put 8, like 8 kilobytes, and then the name of the trace file is swm.prg. So as you can see down here, for the global hits and the local hits and misses, so for both of them have the same value of hits and misses, which are 73.915% and 26.085% respectively. So that's all for the implementation of SMP cache. Tan Boon Kai will continue for the discussion of the SMP cache. Thank you.
So for the part B discussion, the miss rate decrease as the cache size increase because the miss rate means percentage of data access they are not found in the cache, and a larger cache size has a greater number of blocks, which means more data can be handled. The example shown below proves a larger cache has a lower miss rate if compared to a smaller cache. So the decrement does not happen for all the threads because each thread has a different memory access pattern, and both of the capacity and conflict mix decrease while enlarging the cache, because the capacity mix only occurs when the cache is too small for handling data, while the conflict mix only occurs when multiple memory locations map to the same set. So there's no conflict mix in this experiment because the cache was fully associative, and the possibility of conflict mix is eliminated when any blocks can go into any cache line. So when the cache size increases to a certain size, the capacity and conflict mix start reducing while the compulsory rate remains unchanged and makes the miss rate being stabilized. And the great difference miss rate indicates certain programs that have specific memory access pattern which impact the performance of the system. The great difference of miss rate doesn't appear for all the programs because each program uses a different data, and the changes of miss rate are depending on the cache size. As a conclusion, the system performance improves while the cache size because the latency and heat rate is reduced, and the amount of time needed to access data in main memory and the need for the processor to access slower main memory is reduced, which leading to a processing efficiency and better system performance. That's all for my part. Thank you.
So the next part is about the Git. So what is Git? Git is a free open source distributed version control system. It was created by Linus Torvalds in 2005 and has been maintained by Junior Harmono since then. Git helps developers to track code changes, tracking who made changes, and coding collaboration. It also allows the user to see the history of modifications, revert to previous versions, and compare different states of the project. So about the implementation, it only has 3 steps: repository creation, adding collaborators, and creating and committing a text file named member.txt. So this is the proof that all of the members has added their name into the member.txt using the GitHub. So next is the discussion. What is Git version control system and who developed it? What's the difference between Git and GitHub? Git is a free open source distributed version control system. Version control systems are the software tools that help software teams manage changes to source code over time. And it was created by Linus Torvalds in 2005 and has been maintained by Junior Harmono since then. The difference between Git and GitHub is the Git is a software focused on version control and code sharing, while GitHub is a service focused on centralized source code hosting. So the key features of Git is the version control. Git tracks the changes to files over time, who changed it, when the changes were made, and all other important details. This also allows the user to revert changes or compare the changes of the code. The next feature is branching and merging. The Git allows developers to create branches to work on the new features or bug fixes independently, then merge them into the main project. So the benefits of using Git is to improve the team productivity. As Git can track changes, manage projects effectively, and allows multiple developers to develop a project together by creating different branches, then merge it together. So in conclusion, how does Git version control help us manage project source code, especially in mixed language environments with both low-level and high-level programming language? So Git makes the project easier for several developers to work on separate parts of the project with different language without any possible collision of changes. With branching and merging, multiple people are allowed to work on different features without clashing. Changes are always kept in a history log, so developers can check previous changes or go back to how the codebase was before. It plays a key role when you need to find problems related to different languages or basic errors. And that's all for my part. Thank you.
To end our presentation, I would like to share the conclusion of our group project. This project helped us learn many valuable skills, but it also came with a few difficulties. One of the biggest challenges was reading the research papers. Many technical terms and complex ideas were new to us, so we had to reread and do extra research. Another challenge was using the SMP cache simulator. At first, it was very hard to understand how to set up and read the misread data, but after several tries, we figured it out by helping each other and following the instruction carefully. On the bright side, we also gained some benefits. The first benefit was learning how to use Git and GitHub. Before this, we had never used version control tools in real project. Now we know how to collaborate online, push changes, and keep our work organized. This is very useful for future assignment and event jobs. The second benefit was understanding how computers actually work at the deeper level. Thanks to the research paper, we learned about edge computing, CPU simulator, cache memory, and how different system design affect performance. These are not things we usually learn in normal classes. In the end, even though the project was sometimes difficult, it was a good learning journey. We worked together as a team, improved our tech knowledge, and gained more confidence in using tools like GitHub and Simulator. This project didn't just teach us theory, it gave us real skills that we can use in future. Thank you.